Namaskar. So let us now, try to understand how we can send our UART signal to RS-232 transceivers. Okay. So for that, we will try to take one of the pair of UART pair here, UART1TX and UART1RX. Okay. So let us say these two signals are available with us and we have to send it to RS-232 channel. So for that purpose, what I have done is I have selected one MAX3221 series IC. So it has UART side and it will be having RS232 side. So what I will do is UART1 TX is this side and UART1 RX is this side, okay, and TX out, that is RS232 signal, and RX in, that is RS232 signal, okay. So we'll try to understand this data sheet and complete this complete design, okay. So let me open the datasheet of MAX3221 transceivers. So as you can see, this has a lot of part numbers. I'll quickly tell you what is the part that I have chosen for you, or like we have implemented in our circuit. So first part is MAX3221 CAE, which is 0 to 70 degrees centigrade. So it is consumer applications, okay. If you want to increase it little more, for higher industrial application or something, you can go ahead with MAX3221 EAE. So these two parts I'm keeping in my mind, okay. And all right, so with this we will proceed. Our VCC range, as you can see, it is 3.3 volt to 5.5 volt. So we will take up power 3.3 volt, okay. So our VCC which will be applied is 3.3 volt. We have a lot of other parts which is having more than one channel, like you can directly convert two pairs of RS232 or three pairs of that, like that, okay. Now let us proceed to its maximum ratings. So what I'm going to tell you quickly is how to read the data sheet very easily, so that your design becomes quite simple and error free. So as you can see, the VCC absolute rating is zero point 0.3 volt to minus 0.3 volt to 6 volt. So all these things, if you keep in mind, you will not land up giving a voltage to VCC more than this, okay. Otherwise your device will get corrupted or it may get damaged, okay. All right, now moving to next part. As you can see, C part is 0 to 70 degree and E part is 0 to minus 40 to 85 degree, okay. And we have lot of packages like 16 pin TSSOP, 20 pin SSOP, 20 pin SSOP deep, okay, which is through hole. So all these things are there, and power dissipation capabilities are also given. So we will take up 16 pin TSSOP, and first part as well as second part, both design will be same. So let us see the pin configuration directly. It will be easy for us to understand what are the things that we need to design. So as you can see, this series I am taking 3221, which is a single channel transceiver. So pin number 1, which is enable bar. So receiver enable control, drive low for normal operation. If you put it low, it will be normal operation. If you make it high, it will be not working, like high Z state, okay. So what you have to do is you have to ground it. So this is how it will become a normal operation. If you want to control this particular switch, then you have to drive it through a microcontroller pin, okay, and put it 0 for normal operation and 1 for not working. But I'll suggest make it simple. Don't try to drive it or something. You keep it ground. Next, C2 plus and C2 minus, 5 and 6, okay. So that is positive terminal or inverting charge pump capacitor and negative terminal of that. So what we'll do is C2 plus and C2 minus. So here it is connected 0.1 microfarad. This can be a polarized capacitor, but that is not needed. You can connect here simple ceramic capacitor 0.1 microfarad. Okay, so this will be your pin number 5 and this will be your pin number 6. Similar to that, I'll quickly tell you pin number 2 and 4. So this also can be a simple ceramic capacitor 0.1 microfarad. This is also a charge capacitor. Okay, next I'll tell you quickly the VCC voltage supply is like 3.3 volt with 0.1 microfarad here. This also, if you want, you can put it ceramic capacitor 0.1 microfarad. Okay. So these three things are done, right? Next is V minus charge pump, pin number 7. Pin number 7 was what? So as you can see, pin number 7. So pin number 7 is connected with a capacitor 0.1 microfarad. This also can be ceramic capacitor. So all these and these 5 capacitors are there. All of them can be 0.1 microfarad ceramic capacitor. Okay, understood? So you don't have to worry about the polarity of the capacitor because ceramic capacitor will be uh, bipolar, like it doesn't matter any polarities, right? Next, coming to the fact, I will take up these 4 signals little later. Okay, next, coming to the fact that pin number 10 invalid. So output of the valid signal detector indicates if a valid RS-232 level is present on the receiver logic 1. Okay, so what you have to do is uh, this is our 2 power management unit. So you can send it to a MCU pin. Okay, and keep checking whether it is 1 or 0. If it is 1, so like the transceiver is working really great. If it is 0, then it is not working. So, and for that purpose, if you don't want to monitor, then you can keep it not connected. Okay, so this is how invalid signal can be uh, like done. Coming to the fact that force off and force on, right? So as you can see, force on, so if you drive it low, then it will be a normal operation. Okay, and if you drive it high, okay, high, so that you have to drive it through a microcontroller pin again. Okay, so then this can be not working. Okay, like MAX3221 will be stopped. Similarly, if you drive it high, 3v3, it will be working really great, like fine, normal operation will be there. And if you put it low, then like if you put it low, then it will not be working. So force off will also go, I mean force off bar will make it not working. Okay, so for that purpose you have to again drive it through a microcontroller pin. But I'll suggest you make it simple, put it ground. Okay, and put it high with a, let's say, a resistor of, let's say, 100 ohm you can keep. Okay, so 100 ohm you keep and make it high, 3v3. Understood? So force off bar and force on, we have drive low to shut down transmitter. So if you drive low, then transmitter will be shut down. So that's why I'm telling you keep it high. Okay, so that you don't want to shut it down. Next, force on, you drive it high to override automatic circuit keeping transmitter on. So this you don't drive it high, you drive it low. Okay, so it will be a normal operation. Next, C1 minus and C1 plus we already seen. Okay, C1 minus and C1 plus, voltage doubler charge pump. Okay, and ground is already fine. VCC we have connected already. V plus also we have connected. Coming to the fact of these 4 signals. Okay, so pin number 8 is R1 in, R in. So R in is RS-232 receiver input. Okay, so pin number 8 is receiver input RS-232, and pin number 13 is receive transmitter output. Okay, so what we'll do is, this is your RS-232 side. So RS-232 side, what will you do? this will be your RX input, and this will be your TX output. Okay, so this is your receivers. If you come to left side is UART 1 TX. So what I had done is I have these two signal UART 1 TX and UART 1 RX. Okay, from these two pins 1 and 2. So this will be directly connected to the UART pin. Sorry, this transmitter transceiver pin. So this UART 1 TX will be connected to pin number 11, and UART 1 RX will be connected to pin number 9, which is R1 out. And as you can see now that your complete design is ready. Okay, so these two signals only has to be like sent to RS-232 port. Okay, RS-232 port. That's all. So your UART to RS-232 transceiver design is ready. What was the summary? That you take up your UART signal from your microcontroller and give it to the like a transmitter input and receiver output port of the RS-232 transceiver, and take out the signal TX out and R1 in to the RS-232 port. And to keep the design very simple, we are making it fixed. We don't want to trouble this. So enable bar will be always ground, force on will be always ground, force off bar will be always high, and power management, if you want invalid bar signal, that you keep it disconnected. Okay, and all the charge pump capacitors you keep it 0.1 microfarad ceramics. Okay, the voltage level of those ceramic capacitor can be 0.1 microfarad, 16 volt or 25 volt. Okay, and the power supply, as I mentioned, it is 0.1 microfarad. Got it? Now quickly what I will do is I'll give you the like a very good thing that the datasheet itself has. Okay, so it has complete explanation. However, what you can see is from the table of force bar off, you can see when enable bar is 0, then it is active or hijacked or what is there, that we have completed, right? So what I'm going to do is enable bar we have kept 0 and 0, right? So what is happening? If my force off is 1, okay, then enable bar is 0, then transmitter is also active and receiver is also active. Okay, so this is what we want to do. Otherwise, if you just want that RS only receiver should be in coming, then at that time force bar off should be 0. So that we don't want to do. Okay, that's all done. Next is force bar off, we already did, right? Similar to next thing is coming to the fact of, yes, typical circuit diagram. So this is Mauser drive circuit, so that you can go through by yourself. I will tell you the design. So typical operating circuit. So same circuit I had taken these 1, 2, 3 capacitors and 4, 5 capacitors, and these were the UART side, and these were the RS-232 side. Okay, got it? And this enable permanently we kept it down, and this we have permanently kept it to VCC. If you want, you can put a resistor and then put it to VCC. Okay, 100 ohm or even 33 ohm will do. Okay, so that you can ask me. So alright guys, I hope that you have understood the fact like how we can design a very simple RS-232 transceivers for converting UART to RS-232 ports. Okay, so if you do have any questions or any queries or any particular design, like application design that you are looking for, you can always put your comments in the comment box, and I shall be able to answer you out. Thank you so much. Bye.